So, good afternoon, students. Uh, Today we are going to discuss about the experiment number 6. As you can see here, the name title of the experiment is to study the balanced three-phase system for star and delta connected load. So, in the previous theoretical discussion which we have made on 3rd January 2022, we said what is three-phase load, and three-phase loads can be connected in star or delta. That we have discussed. Now, here this Y is representing the star connection, this delta is representing the delta connection. So we will have to take a three-phase load. In that, we will have to give a three-phase supply. Three-phase supply means in the theoretical class I have said you, it will have three phases and the voltage of each phase will be 120-degree electrical apart from each other. So if we normal convention which we use in India is the R, Y and B. So R phase, if we take as reference, its magnitude of voltage if it is VR angle 0 degree, then the Y phase voltage will lag by 120 degree with respect to R phase. So Vy will be phasor will be Vy magnitude angle minus 120 degree. Minus 120 degree why? Because it is lagging the R phase by voltage by 120 degree, and B phase similarly will lag 240 degree with respect to R phase. So it will be Vb minus magnitude angle will be minus 240 degree. So if we come to the circuit diagram, we will have to find out the relationship between the phase voltage and the line voltage, phase current and line current in two different connection, that is star connection and delta connection. So what should be the relationship? In star connection, line voltage should be √3 times of the phase voltage, and line current and phase current should be equal. In delta, line voltage and phase voltage should be equal, but line current should be √3 times of the phase current. How? So this is the star connection load. Here we are using a resistive load in this case. So this is one phase A2 to A1, then another phase is B2 to B1 and C2 to C1. Here three inputs of supply: R phase supply, Y phase supply and B phase supply. Here this is the three phase wattmeter. In single phase wattmeter we are aware of the names M, L common and V. Here also M, L, CV is there for one phase. For other phase also similarly M, L common and V. So M1 and L1 we know main terminal, line terminal, common is common terminal and V is the voltage terminal. Here also for other phase M, L main is the main terminal. You see the supply is coming from main here. Then M is shorted to V, and then from L the current power supply is going to the load. Here also from M it is entering, M and V are shorted, and from L it is going to the load. Both the common are internally shorted. During experiment we do not require to sort them. It is internally shorted, but any one of the common terminals should be connected to the Y phase. That means both the common terminal we can say indirectly is connected to Y phase. Now this is the three phase system, inputs into the loads, three wires. So the voltage between the two lines of two different phase is the line voltage. So here this is one phase, its input is this wire. This is another phase, its input wire is this one. In between the voltage will be the line voltage, and the corresponding current flowing through this line will be the line current, and this is phase. So if we want to measure the phase voltage, we will have to connect a voltmeter between any phase, between the two terminal of the phase. Either we can connect it between A to A1 or B to B1 or C to C1, anything, to measure the phase current through the phase resistance, particular phase resistance, how much current is flowing, that we are measuring. Here we are measuring this current for two phases, for B phase and R phase. A1 is ammeter that is measuring the current of B phase, and A2 is the ammeter which is measuring the current of A phase, and A3 is the ammeter which is measuring the line current. So if we want to find out the relationship between line current and phase current, we will have to find out the ratio between the A3 ammeter reading by and A1 or A2 ammeter reading. Similarly, if we want to establish the relationship between the line voltage and phase voltage, in that case we will have to find out the ratio of this voltmeter reading divided by this voltmeter reading. So that is the thing we will have to perform. So what are the apparatus we are using here? We require 1, 2, 3 ammeters, 2 voltmeters, 1 3-phase wattmeter, and here variable AC supply is there. For that we require a variac, 3-phase variac, because it is a 3-phase supply. Same circuit we will have to make for the delta connected load also. Connection of wattmeter is same. Between the line, if we see, this is one phase, this is another phase, this is another phase. If we want to find out the line voltage, input line of one phase, another input line, between R and Y we are connecting a voltmeter. So it is measuring the load voltage, line voltage across any phase. Suppose B phase we are measuring here, B1 and B2 we are connecting a voltmeter which is measuring the phase voltage, and corresponding phase current for B phase it is measuring the corresponding. For C phase it is measured by this ammeter, for B phase it is measured by this ammeter, and the corresponding line current is measured by this ammeter. So two ammeters are measuring two different phase volt current, and one ammeter is measuring the corresponding one line current. So if we want to find out the relationship between phase voltage and line voltage, we will have to make a ratio of the reading of this voltmeter and this voltmeter. If we want to find out the relationship between the phase current and line current, we will have to find out the ratio of ammeter reading of this ammeter or this ammeter with this ammeter. What are the readings we will take? We will measure the line voltage, phase voltage, line current, phase current. Then we will find out this ratio. Power factor, how to calculate, that I will discuss later on. Wattmeter reading, using this wattmeter connection we will get the wattmeter reading. So this active power of wattmeter reading, that we will be able to get it. Then we will calculate the power also using the 3-phase power calculation formula as well. Here for 3 different value of, since here you can see the load which is mentioned, here one arrow symbol is given, so it is representing a variable resistance. So our load of 3 different phases are variable loads. So what we are doing, we will vary the load to different value, 100% load connected, 50% load connected, 10%. We can set any different value also, 90%, 45%, 20%, anything. For 3 different values of load, we will have to find out this ratio, and we will have to check the corresponding reading, and all those values we will have to see. So let us see our panel. Before going to the panel, how the 3-phase variac looks like, let us see that one. You see, this is the 3-phase variac. It's a big one. Here this is the terminal through which we are varying the voltage. So it is connected at this moment at 0 point. If we want to increase the voltage, we will rotate it like this. So you see, we are increasing the voltage. Again, if we want to make it 0, here it will be automatically stopped. You see, I am trying to rotate it, it is not. This is the internal circuit diagram of this 3-phase variac, and from the, since it is a 3-phase variac, you can see 3 wires are coming out of it for 3 different phases. That's all. Now this input supply we are giving to whom? To the R terminal, Y terminal and B terminal. So in the panel we are bringing the supply, 3-phase supply through this variac. So the panel Now in this panel, now in these three terminals, we will get three-phase voltage. Now, if we see this one in the panel itself, all the three ammeters are there. We do not require to connect any external ammeter in this set. Three ammeters, you see it is written. This is measuring AY, this is A2, this is measuring A1, this is the ammeter A3. So as per circuit diagram, you please check it. The circuit diagram which you are having in the manual. So you will be able to understand which ammeter is measuring which thing. This is A3, this is A2, and this is A1 ammeter. We require 2 voltmeter. This is 1 voltmeter, externally connected voltmeter. This is another externally connected voltmeter. So this voltmeter is having two scales. One is 150 volt scale, another is 300 volt scale. Here in the scale also you can see three ranges are there, 0 to 150, 0 to 300. If I connect the wire at the between common and 300, so we will follow the upper scale. If I connect that wire between 0 to 150, I will use the lower scale. Similarly, for this one also, it is also having two ranges, 150 and 300. Since we are dealing with three-phase supply, so if we see in India, normally in LT level, three-phase supply voltage, line-to-line voltage is normally 400 volt and above. Phase voltage around 220 volt and above. So since 220 is greater than, even if it is a phase voltage, so since it is greater than 150, so we are preferring for safety side to connect it at 300 volt terminal during our experiment. We could connect anywhere also, but here we are not. But you may ask me, sir, your reading is less than 150, then why have you not connected to 150? Okay, maybe I am keeping the input voltage lower, but maximum we can increase up to that voltage. So that's why we are keeping it at the connecting it at 300 volt. This is our three-phase wattmeter. You can see the scale is 0 to 1200 watt, but when for normal condition. This wattmeter, if you see the voltage scale, there are two voltage scale, 300 and 600 for both the phases. Here also you can see 300 and 600. Current, here if two ranges are there, here you see 2.5, it is written 2.5 and 5 ampere. When it will be 2.5, when B1 and B2 will be shorted, it will be lower range, and if B1 will be connected to E2 and B2 will be connected to E1, through this you can see we can change the position like this shunt, and correspondingly we can make the connection like this. Just a minute. You see, if I connect it like this, then the current range will increase to 5 ampere. But we will not increase the current range much in this case for safety purpose. We could increase, but I am not increasing at this moment. You don't think that it cannot be increased for this panel. It can be increased, but I am not increasing it at this moment. So just a minute. Yes. You see, I am sorting it. So lower range of current will be there, 2.5. So voltage is at 600 volt, voltage scale, current scale is 2.5 ampere. So what will be the multiplying factor? You see, current is 2.5, voltage is 600, it is showing 2 multiplying factor. If it would be 5 ampere, 600, multiplying factor would be 4. So multiplying factor is 2, means whatever reading it will show, we will just multiply it by 2. That will be the exact power consumption of this circuit. This is the 3 rheostat. which is representing the three phase loads. This is one phase load, this is another phase load, this. The wire of these loads are internally connected and coming to this terminal A1, A2, B1, B2 and C1, C2. So instead of connecting the terminals here, I will connect the terminals assuming these are the terminal A1, A2, B1, B2, C1, C2. So I have made the connection according to this. As for example, if we see the wattmeter connection, what we need to do, M should be sorted with V, supply should come to M. Let us see from R phase, you see from the R phase I have taken it, it is connected to M. Then M and V will be sorted, M and 600 volt is sorted. From L it is going to load, that means A2 terminal. It is going to load. You see this is yellow wire. Okay. Similarly, for this also M2 and V2 should be sorted. You see this is our M. So you see this M and V are sorted. M and V are sorted. From L, this is the L, it is going to load. Where it is going? It is going to load but via ammeter, because you see here one ammeter is there. From this we are taking one ammeter. From L it is coming to one ammeter A1. From A1 it is going to the load. So you see here it has come from L to A1, A to L, A1, and from here it is going to the corresponding load. Which phase load it will go? It should go to corresponding this B phase load. So you see it has come to the B phase load. And for the corresponding your A phase, from A phase you will see one ammeter is going connected. So let us see, this is ammeter, it will be ammeter from A phase. Let us see, from R it will go to L1, it will go to A2. So let us see, from here L it is going to A2. From A1 it will go to one ammeter. From ammeter it will go to common terminal of A phase, B phase and C phase. Common terminal of A phase, B phase, C phase means A1, B1 and C1. Here you see B1 and C1 are sorted. A1 is sorted via ammeter, connected to B1 via ammeter. So this is the connection in voltmeter. This is the corresponding line voltage measurement. So between R phase and Y phase we have connected. You see this between R and Y, this is measuring line voltage, and phase voltage should be measured by whom? By this voltmeter. It should be connected between A2 and B1. So let us see this one. This is connected between A2. You see this red wire A2, and this will be connected to B1. You see this is connected to B1. So this is the connection what we have made actually. Now I will increase the switch on. First I will have to switch on the MCB. Already the MCB is on. This is the 3-phase MCB. Actually 4 points are mentioned because it is having a neutral connection also. 3 phases, RYB and a neutral. So normally 4 points are there in MCB, miniature circuit breaker. So if it will be in upside, this is on. If it is in the downside, it is off. I am switching it on. You see red color, it is written on. So these are on. Now the supply is coming where? Supply is coming through this wire into the variac, and this is the output terminal of the variac. Now I am increasing the voltage. You go and show the voltmeter reading. When it will be 140, you tell me it is 140 already.
কম আছে তাই
So it is 140. So input voltage, this is measuring the line voltage, is 140 volt. What is our phase voltage? This is the phase voltage measuring voltmeter. How much is this? We have connected it to 300 volt range. So upper scale we will follow. It is 80. It is after that 82, 84, almost 85. So 85 volt is the corresponding, or 84 volt is the corresponding uh, voltmeter reading. Not 84, rather we can say 83 volt is the corresponding voltmeter reading. Be careful, you can see in this voltmeter or any type of such type of meter there is a mirror. So whatever pointer is there, its image will be there in the mirror. So we should put our eye in such a position where the mirror image of this pointer and this pointer should collide. Your eye should be in that position, that time only you should take the reading. Otherwise, parallax error will be there. So let us see the wattmeter reading. Wattmeter reading is it has crossed this is 200, so 50% will be 100. This is 50, so 50, 100, 150, 200. So 50, it is almost, we can say it is in the range of 50 only. Yes, so 50, but since our multiplying factor is 2, that means 100 watt. So reading is 100 watt, line voltage is 140 volt, phase voltage is 83 volt. Now let us see our corresponding A1, A2, A3 meters reading. A3 is giving the line current. It is 0.4, 0.5, 52, 54, 56, 0.56 ampere. This is also this is A2 ammeter. It is slightly more than this. It is, for that we will have to adjust the resistance only, nothing else. Because it is very difficult to set all the, there is no marking on the load that this is the equal position. So it is difficult to say. So we will have to adjust the value almost. Let us keep it in the middle position. So in this case, almost we are finding it around 0.56. This is also in the range of 0.56, but this is A1 is slightly less. It is in the range of 0.53. So you note down 0.53. There will be some difference because you can see here, if you see the loads are, there is no marking that this is the equal position. Each are not identical specification wise, but manufacturing wise there can be some differences. So to identify exact same location for each of them, it's a bit difficult. But if we see A3 is showing us the line current and A2 is also showing us the line current, phase current. So it is almost equal, so we can say line current and phase currents are equal. Now similarly we will vary the resistance. You see, we are increasing the lowering the resistance. So if you see, this is the another position. In that case, what we can see is that so here you can see it is 0.9 almost. This is also 0.9. A3 is 0.9, A2 is 0.9. This is slightly, A1 is slightly less, around 0.86. So why this A1 is changing slightly? Here between A2 there is ammeter additionally for this A1 additionally, but for this part there is no additional ammeter in this, so there may be some difference in the reading. But you can say, if we see A2 A1 and A2 is one is showing you correspondingly A3 and A2, if we see, then one is showing you the phase current, another is showing you line current. You can see this is also in the range of 0.9, this is also in the range of 0.9. So line current and phase current relationship is equal, that is established. Now we are increasing the resistance and reducing the current for the third case, so that we can reduce the corresponding current. So here you see the corresponding your currents are 0.4, 0.4, 0.4. In that case line voltage is remaining same 140 volt, because it will not change. Phase voltage has slightly almost it is supply voltage is not changing, 83 is remaining, because we are not varying the voltage, we are varying the resistance of the load, so current will change. Here as the resistance is changing, load value is changing, so correspondingly power consumed will change. So in that case if we see, it is in that is in the, you can say this scale is 50, then it is around 1 2 3, less than fourth scale, that means less than 40, around 37 38 we can assume. So 37 38 if we assume, then correspondingly into 2, that means 76 watt. Previously when we have shown 0.9 ampere current, that time also voltage was remaining same. Let us go to that position once more, because we will have to see the wattmeter reading that time also. You see, I am changing the resistance.